Okay, this problem is similar to number 8 on section R.8. Since this problem deals with cube roots, let's first talk about perfect cubes. 1 is a perfect cube since 1 cubed is equal to cube. The next 1 cubed is equal to 1. The next perfect cube is 8. 8 is a perfect cube because if you take 2 and cube it, you get 8. So then if you take the cube root of 8, it will just be 2. Alright, let's do what's 3 cubed? 27. Nice perfect cube because that's 3 cubed. 4 cubed is 64. Nice perfect cube. Next one's 125 and so on. I'm going to stop here. 125 is 5 cubed. Alright, these numbers on the left are called perfect cubes because all these integers, they're whole numbers really. If you cube them, you get the left-hand side perfect cubes. Alright, so we want to keep this list in mind when we're going through this problem. When you are trying to add or subtract radicals, you can't do it unless they're like. You cannot combine the cube root of 2 with the cube root of 16. So we need to do some simplifying. You cannot simplify the cube root of 2. 2 is not a perfect cube. It doesn't have any factors of it that are perfect cubes. But let's look at 16 over there. The cube root of 16, again 16 is not a perfect cube, but look at these lists of perfect cubes and we want to find a factor of 16 that is a perfect cube. If you see this 8 right here, so what I'm going to do is use a property of radicals that says that you can break apart radicals into a product of those similar radicals. So since these are cube roots, cube root of 16, 16 is 8 times 2. So you can write it that way. This is a property of cubes. Do my cube root there, my bad. Property of cubes says that cube root of 16 is equal to cube root of 8 times the cube root of 2, because 8 times 2 is 16. Alright, so at the next step we actually want to take that cube root. Let's keep everything else the same. The 9 is out here. Remember, this is multiplied together. So the cube root of 8 over here is 2. Alright, the cube root of 2 you can't do anything with. Let's leave it there. So we're just about done. Got a couple more steps. Let's still keep this out front. I cannot do anything with it. Not yet. 9 times 2 is 18. Cube root of 2 stays back here. Now, if you see, I've got a cube root of 2 here and a cube root of 2. These are like radicals. They have the same index, which is 3. They're both cube roots. And the radicand, what's inside, are both 2s. Those match. These are called like radicals. That means you can combine those coefficients, the numbers out front, 3 of these minus 18 of these is going to leave me with a negative 15 of these, which are cube roots of 2. Alright, and that's the answer. So your problem will be similar. It'll have different numbers, but what you want to keep in mind, especially if you're dealing with cube roots, are these perfect cubes. And you can just list them out if you want to, but keep these in mind when you're dealing with cube roots, those perfect cubes. Hope that helps you with that one.